Hello and welcome back to my channel. My name is Amir and this is day 10 of the Advent of Code 2022. So let's get started then. Okay, we are working on a category tube. We have been given a input like this in this format. So either we have a no op or we have an addx command. If it's a no op, we should do nothing, but if it's an addx, we need to add this value to the x, and we have only one x value that is being changed. And so far this looks like an easy program. Let me read through the example here. At the start of the first cycle, so we have bunch of cycles, so we have a cycle that is going on like the CPU cycle. When the new op instruction begins execution, during the first cycle nothing happens and x is still 1 because we started with 1. After the first cycle is done, the no op instruction is done, finished, and then we do nothing. Okay, this is with the no op. Then we get to the second one. At the start of the second cycle, the add x instruction begins, but it's not completed yet. During the second cycle, x is still 1. During the third cycle, x is still 1, and after the third cycle is done, the addx instruction finishes execution, setting x to 4. So, like every addx, takes 2 cycles to complete, and after the 2 cycle is complete, this addition takes place. During these 2 cycles, the x is having the value that it had beforehand. Okay. Then we can do something else. So maybe you can learn something by looking at the value of x register throughout the execution. For now, consider the signal strength. So we are looking at the special cycles like 20th, 40th, and so forth and so on. The 20th, 60th, 100, and 140, and 200, 20th. So if we're looking at this big input, during the 20th cycle, the register x has the value of 21. So the signal strength is 20 times 21, 420. And it's in the middle of adding x, so it's taking the x value which is current, not the value that is being added minus 1 to it. Okay, then we need to multiply these two values together, the value of x and the cycle, and then add these values together to get the final output that we want. Okay, so let's go and do it then. So what I should do is first say let x is 1 because we are starting with 1, and we get another variable called op, set it to 0. We have a signal strength which is our final result that we want to show. Set that to 0 as well, and we have a bunch of cycles that we are interested in. The values are these values. So I need to remove the th from here and the and value. Okay, these are our cycles. What should I do? I should say for every line, let every line in our input, what should we do? We should do one of the two things. If the line starts with say no op, then what should we do? We should add 1 to the operation or operation, and then say if we are in the cycle that we are interested in. So if cycles includes the operation that we are looking for, then the signal strength should be updated with OP times X. Okay. Thankfully we have two instructions, so we shouldn't bother with writing another if. So if we are in add X, we need to wait 2 cycles, so 2 of these operations. These could very well go into a function because we are repeating one thing 3 times, but that's fine here. And then in the end, X should be updated because 2 cycles has passed. So I would say line dot split by, let's say, space, and then take the 1. So this means that, so for example in this here, if we have add x minus 6, this is our line, we are splitting by space and we are taking this minus 6, but we need to convert this to a number, so we say number of this value. Okay, so when our 4 is done, we should get the value. So it should be signal strength, and we should be fine. So let me check with the sample input, node part 1, and it's 13140, which I believe is the correct value. 1314, yes, it's correct. So let's get the input puzzle and see. If I save this one and then I run this one, 12980, come here, get this and submit it. Yes. Okay, cool. So let's get to part 2 then. Okay, this part is a little bit trickier. So it seems like X register controls the horizontal position of a sprite, this one. Specifically, the sprite is 3 pixels wide and the X register sets the horizontal position of the middle of the sprite. Okay, in the system there is no such thing as vertical position. Okay, so this is, which means that this is a one-dimensional array. Okay. If the sprite's horizontal position puts its pixels where the CRT is currently drawing, then those pixels will be drawn. Okay. So it's a 3 pixel wide, and if the sprite's horizontal position puts its pixel where the CRT is currently drawing, so if those values are the same, then the pixel should be drawn. Okay. We have a CRT which is 40 wide, like this, and it's 6 columns. It's 40 columns and 6 rows. So row 1, row 2, row 3, row 4, row 5, and row 6. Okay, and thankfully they are starting at position 0, so this is position 0. And we go on to 39 and so forth and so on. Okay. But our cycle starts from 1 and so forth. So like the CPU, the CRT is tied closely to the circuit, to the clock circuit that it has. And then the CRT draws a single pixel during each cycle. So okay, so it's basically the same CPU clock like the CRT. We shouldn't bother with that one. And if we carefully time the CPU instructions and the CRT operations, you should be able to determine whether the sprite is visible So we are on the same cycle, and based on these, or can we draw it or not? Okay, there is a thorough instruction here, which I don't want to take your time reading it, but you should do that. And after that is done, we can see that uh, we can draw something like this in the CRT or in the console or whatever they want to call it. So probably if we run that, we would get an 8 capital letters that appear in our CRT or in our console. So I think you should read throughout this and find it by yourself, that what is going to happen after setting up the CRT and the CRT clock and the CPU clock. But I will write the code as I go along. So let's get to the code. So let me copy from here to here and then make some changes. First thing is that we have a current x value, which is 1. Our current value of x, let's do it like this. Current value of x is 1, and our x is not just a one value. We have a array because we have like 240 positions here that we need to fill. So I would say this is a new array of 241, going from 0 to 240. This makes much easier. And then I'm adding all with 1. I'm filling all with 1. So in the first cycle, x is an array of 240 places, all filled with 1. Then I have an operation which is 0. I don't need to bother with these two anymore because I don't need them. And for every line, if our line is like no OP, then we add the OP, but we don't care about this one. We just say x at position of OP is our current x. So this is done. Otherwise, we say that x at next position is current x, and then current x is the number of the line split by space and taking the first one, and this should be current x plus equals that thing. Okay, so this is after the first operation, and then we need to, this is the part that is a little bit complicated. So we add 2 to the OP, and then we say that x on the OP is our current x. So this is the way that it works with the clocking and everything in the CRT and CPU. If you don't understand it very well, I urge you to go and read the instruction. It will become pretty clear to you. So I think this is working fine. Let me go to the next part, which is writing these values. So I will have a, let's call it CRT array. It should be 40 by 20, so I will say give me a array of 40 and then fill it with nothing, and then map each of those to a new array of length 6. So we have a 40 by 6 row and column display, so to say. To have two for loops, one for the row that starts from 0 and goes to 6, and I'm adding the row, and then I need another one for the column that starts from 0 and goes all the way to 40, but not the 40 itself. Cool. Then what I should do, I should get the index, which is row times 40 plus column plus 1. So this means that, for example, if we are here, we get 0 times 40 plus 0 plus 1, which is cycle 1. And then if we want to, if we want this one, for example, then we say 5, which is this value, times 40 plus 39, which is the end of this one, plus 1, which is 240. Okay, so this is our index. Then if the absolute value of the x at one index before what we are looking at minus the column that we are interested in, if this value is either 1 or is less than 1, then what should we do? We should just get the CRT array at that row column and say, like, for example, we should draw, basically, which I would say, like, for example, plus. I would draw a plus there. Then otherwise I would draw nothing there. I would put a space there. So this is done with the for loop. Yes, so let's go and see what we get. So for every row of that CRT array that we have, just merge the row values together and join them together, but by nothing, and then just display the value. Okay, so let's get the test, which is this one. And put it here and save it. Now node part 2. Okay, so we are getting something like this here, which is similar to what we have here. Okay, so maybe I need to have like a queue to make it more clear. Okay, makes sense. This is basically the same as this one. Yep. So let's get the input and try with that one. Okay, this is not very clear. Let me say this, maybe. And then what do we get here? Now I'm getting something BRJLFULP. BRJ. So what we get is BRJLFULP. Yes, so I urge you to go and read the part 2 because it's very interesting to find out about the CRT and the CPU cycle and everything, and maybe try the code by yourself. try right click it by yourself and see what you come up with. So as always, if you found my video interesting, please comment and like and subscribe to my channel. It really helps me. Thank you for today. Have a great day and see you tomorrow.